Let's look at another example involving substitution. Let's evaluate the definite integral. The integral from 1 to 5 of x over the square root of 2x minus 1 dx. So again, you look for your composition, part with an inside and an outside. That's in the denominator. So I'm going to make u be 2x minus 1. So then du will be a 2 dx. And I'm going to solve for dx, so I'll get a 1/2 du equals dx. Now I can change over this dx here, and I can change over the denominator, but I have this extra x I need to get rid of. So you're going to go to your substitution equation and solve for x. X will be u plus 1 over 2. And the last thing we have to do before we start our work on the problem is we need to change our bounds on our integral. So before, our lower bound was x equals 1. What does that correspond to now? So if I plug it in, u is 2 times 1 minus 1, or 1. So I have the same lower bound, but if I plug in x equals 5 now, what will my new upper bound be? U equals 2 times 5 minus 1, or 9. All right, so we're ready now. We've done everything we need to switch over and do our substitution. So the first thing is my bounds change 1 to 9 now, are my new bounds. In place of x, you're going to use u plus 1 over 2. And then in place of this denominator, you're going to have 1 over the square root of u. And finally, in place of dx, you get a 1/2 du. So I'm going to pull out both 2's out of the denominator. I'll get a 1/4. This is u plus 1 over u to the 1/2. And then you're going to separate it out. This is u to the 1/2 plus u to the negative 1/2. And then from here, you're going to do your reverse power rule, u to the 3/2 over 3/2 plus u to the 1/2 over 1/2 from 1 to 9. You don't need to write a plus c because we're doing a definite integral here. So now you're going to plug in 9. Maybe first we'll go ahead and distribute this 1/4 out. So you're going to get a 1/6 u to the 3/2 plus a 1/2 u to the 1/2. So this is 1/6, 9 to the 3/2, from 1 to 9 here, plus 1/2, 9 to the 1/2, minus, and plug in 1, you'll get 1/6 plus 1/2. So here you're getting, for this one, it's the square root of 9 cubed. So it's 3 cubed, or 27. 27 over 6 plus 3/2 minus 1/6 minus 1/2. So if you combine these two, you'll get 26 over 6. If you combine 3/2 minus 1/2, you'll get a plus 1. So in total, you're going to get 32 over 6, or 16/3 as your answer. Now I do want to mention on this problem, you could have made a different substitution. It's not a conventional one, but I think it's still worth our time looking into. So for this problem, you can make a different substitution. So let's relook at our integral here. It was 1 to 5 x over the square root of 2x minus 1 dx. So this other substitution you could make, you could have chosen u to be the whole square root. Now we want to take the derivative of this, but it's a little messy with a square root, so let's square both sides. U squared 2x minus 1. And if you solve for x, you're going to get x equals u squared plus 1 over 2. So now if you take the derivative of this equation here, you'll get dx equals u du. So we've got everything we need, except we need to change our bounds, right? So if x is 1, what's u going to be? U will be the square root of 2 minus 1, the square root of 1, which is 1. If x is 5, then u will be the square root of 10 minus 1, square root of 9 is 3. So my new bounds will be 1 to 3, 1 over u, and then in place of x, you're going to put a u squared plus 1 over 2, and then u du in place of dx. So I can pull out the 1/2. These two u's cancel. The integral from 1 to 3 of u squared plus 1. So this will be 1/2 u cubed over 3 plus u. And you plug in top number, 1/2 3 cubed over 3 plus 3 minus 1/2 1/3 plus 1, and if you simplify this down, you'll get 16 over 3, which again was the exact same answer we got earlier. So here, for this particular problem, there was a different substitution we could make. So there wasn't just one choice for our u for this particular example.